I'll be explaining my code for assignment 5. There are multiple requirements that I had to code. The assignment 5 requires to create a family tree, the class that will represent a family tree for a given family. The class should contain several types of relationships that commonly happen within a family, for example, siblings, marriage, offspring. The second requirement is programmatically adding the family members to the graph as described by the accompanying family description file, the Word doc that the professor has provided. Another requirement is to give data assertion to the family tree class to enforce restrictions for basic family structure, at least 3. And another requirement is to provide a simple CLI that enables users to add, remove, and edit family members, which I have done. So I have 3 file structure here, FamilyTree.py, graph.py, main.py. So all of these files are necessary. They support each other. So first I'll be going over the graph.py. So as you can see, I've actually used the professor's code to support my own code. I have tweaked a little bit, which tweaked the code a little bit, which I will explain. So as you can see, we have the first 2 duplicate vertex exceptions here that I will use to raise errors. So the duplicate vertex exception and duplicate edge exception, these are custom exception classes inheriting from the base exception class. They are used to raise exception when attempting to add duplicate vertices or edges to the graph. Next, I have coded the graph class here. This is the main class representing a weighted graph that will be used to construct the family tree. In the graph class, I have the init method. This is the constructor method for the graph class. It initializes the graph with empty dictionaries to store the vertices and edges. So I have self.vertices, which is a dictionary that maps a vertex ID to their corresponding vertex objects. And then I have the self.edges, a dictionary that maps pairs of vertex IDs to their corresponding edge objects. Next, I have the vertex class within the graph class. This is the inner class representing a vertex in the graph. Each vertex has an ID, name, gender, and age. These were the requirements of the assignment. It is used to encapsulate the data of each family member. Next, I have the graph class. This is an inner class representing an edge in the graph. Each edge connects 2 vertices, vertex 1 and vertex 2, and has a weight that represents the relationship type. It is used to store the relationship information between the family members. Next, I have the add vertex method. So let me scroll above here. The add vertex method is used to add a new vertex family member to the graph. It checks if the given ID already exists in the graph's vertices dictionary. If it does, it raises a duplicate vertex exception. If the ID is unique, it creates a new vertex object with the provided data, name, gender, age, and adds it to the vertices dictionary. Then it returns the newly added vertex object. Next, let's take a look at the add edge here. The add edge method is used to add new edge, also known as relationship, between the 2 vertices in the graph. It checks if the edge already exists by looking for both ID1, ID2, and ID2 and ID1 in the edge dictionary. If it does, it raises a duplicate exception error. If the edge is not a duplicate, it retrieves the corresponding vertex objects for the given IDs. It then creates a new edge object with the provided data, vertex 1, 2, and weight, and adds it to the edges dictionary. Then let's take a look at the remove vertex function. The remove vertex method, this method is used to remove a vertex from the graph along with all the edges connected to it. It takes a vertex ID as input and checks if it exists in the graph's vertices dictionary. If not, it raises a value error. It then iterates through the edges dictionary to find all the edges that connect to the given vertex and removes them. Finally, it removes the vertex from vertices dictionary. Let's take a look at the next method, getVertexByLabel method. This method is used to retrieve a vertex family member by its ID, also known as label here as a variable, from the graph. It takes the vertex ID as input and returns the corresponding vertex object from the vertices dictionary. If the ID is not found, it returns none. The next function is getNeighbors. GetNeighbors method. This method is used to retrieve the neighboring vertices, family members of a given vertex along with their edge weights, relationship types. It takes a vertex object as an input and iterates through the edges dictionary to find all edges connected to the given vertex. It builds a dictionary of neighboring vertices and their edge weights relationship and returns it. The next method is getVertices and getEdges method. These methods will be used in the FamilyTree class. These methods are used to retrieve all vertices and edges in the graph respectively. They return lists containing all the vertex and edge objects presented in the graph. The last method I have built here is the print family tree. This is just an extra method that I have added to just for testing purposes and to print out the tree itself and the neighbors. This method is used to print out the family tree stored in the graph. It iterates through all the vertices and prints their ID, name, and age. It also prints the neighboring vertices, family members of each vertex, if any. The graph implementation provided in this code will be used as the backing structure for the family tree class, which will provide higher level methods and data assertions specific to managing the family tree. Next, let's take a look at the family tree here. As you can see, I have used the graph. I've imported the graph from my graph class to build to use its methods and behaviors. So let's take a look at the family tree. The code above, the init method, this is the constructor method for the family tree class. It initializes the class by creating an empty graph object, which will be used to store the family tree relationships. Next, I have in the add relationship method, I have the 3 required data assertions. The add relationship method is responsible for adding relationships between family members. The 3 data assertions, also known as validations, are implemented to enforce certain rules in a typical human family. So let's take a look at 3 of these. Data assertion number 1. A person cannot have a relationship with themselves if a person 1 and 2 are the same. A value error is raised. Data assertion number 2. A person cannot be their own parent. If the relationship is parent and person 1 and person 2 are the same, a value error is raised. Data assertion number 3. Siblings cannot marry each other. If the relationship is spouse and person 1 and 2 are siblings, a value error is then raised. The next method is are siblings. This method is used to check if 2 given family members are siblings. It utilizes the graph class method, getNeighbors, to get the parents of the 2 family members. If the 2 family members share a common parent, they are considered siblings. Next, the add family member method is used to add new family member to the family tree graph. It takes the ID, name, gender, age as input parameters to create a new vertex family member in the graph using the graph class method, add vertex. It returns the created vertex representing the new family member. Next, the add family method. This method is used to add relationships between the family members in the tree. It calls the graph class method, addEdge, to create a weighted edge between the 2 given family member vertices representing the relationship. Next, the edit family member method allows for editing the name or age of a family member. It takes a person node representing the family member vertex to edit the new name or the age. If a new name is provided, then the name of the family member represented by person node is updated. If a new age is provided, the age of the family member represented by the person node is then updated. The next function is remove family member. This method is used to remove a family member from the tree. It takes a person node representing the family member vertex to be removed. It calls the graph class method, remove vertex, to remove the family member vertex and any edges associated with it. Next method is getFamilyMembers method. This method returns a list of all the family members in the family tree. It utilizes the graph class method, getVertices, to remove all vertices representing family members. The next method is getRelationship. The getRelationship method, this method is used to get the relationship between 2 given family members in the family tree. It takes person 1 and person 2 representing the family member vertices for which to find the relationship. It utilizes the graph class method, getEdges, to retrieve all the edges between person 1 and person 2 representing the relationships. GetFamilyMemberByName method. So we have the getFamilyMemberByName method. This method is used to retrieve a family member by their name from the family tree. It takes name as an input parameter, representing the name of the family member to search for. It iterates through all the vertices using the graph class method, getVertices, and returns the vertex with the matching name. If no family member with the provided name is found, it raises a value error. Then we have the getFamily method. This method is used to retrieve all the family members belonging to the specific family by the family name. It takes family name as an input parameter, representing the name of the family to search for. It iterates through all the vertices using the graph class method, getVertices, and adds vertices with matching family names to the family members list. It returns the list of vertices representing family members belonging to the specified family. Overall, the family tree class provides methods to add, edit, remove family members, add relationship between family members, retrieve family members by name or family, and check sibling relationships, all while ensuring data assertions to enforce to enforce basic family structure rules. The family tree data is sorted in the form of a weighted graph using the graph class. Lastly, let's take a look at the main.py. This file acts as the CLI for user inputs. The main method imports FamilyTree from FamilyTree class. The code here, the family tree is represented as a graph structure, the family members as vertices, relationship as weighted edges. Here's my explanation of the code. So first, we have create family member method here. This function is used to prompt the user to enter information, such as ID, name, gender, age, to create a new family member. Then it takes inputs from the user and returns the entered data as a tuple, ID, name, gender, age. Then I have built my main function here, which I have fulfilled the requirement to programmatically add the family members to the graph as described by the accompanying family description file. So I looked at the description file and manually programmatically added all the family members here. So as you can see, I used the family tree object to use the add family member function. As you can see, I have the first parameter, which is the ID, name, gender, age. And I did that for the rest of the family that was listed on the file. And I've also added the relationship here. These are all the relationships. Then I actually have, I built a menu. So I say while the program is running, print out the menu. Then the user is supposed to, so the main function is the entry point of the program. It initializes an empty family tree object and adds the family members with the respective attributes. It also adds a relationship between family members based on the provided data. So while true, the program runs in an infinite loop, displaying a menu of options to the user until they choose to exit. So let's take a look at the menu options. We have add family member, add relationship, edit family member, remove family member, show family members, and exit. So option 1, add family member. The user is prompted to enter information for a new family member. The add family member method of the family tree class is called to create and add the new family member to the family tree. The entered data is then displayed as a confirmation. The option 2, add relationship. I use the if statement to get the user input and basically switch between the choices here. So if the user chose add relationship, which is option 2, then option 2 behaviors are executed. So the user is prompted to enter the names of 2 family members and their relationship. The get family member by name method of the family tree class is used to get the corresponding vertices nodes representing the family members. The add relationship method of the family tree class is then called to add the relationship between the 2 family members. Then the entered relationship is displayed as a confirmation. For option 3, edit family member class, the user is prompted to enter the name of the family member to edit. The user enters the family member's name. The get family member of the family tree class is called to get the list of the family members within the given name. The user is then asked what they want to edit, name or age. The edit family member method of the family tree class is called to update the name or age of the family member. Option 4, remove family member is option 4. The user is prompted to enter the name of the family member to remove. The get family member by name method of the family tree class is used to get the corresponding vertex representing the family member. The remove family member method of the family tree class is called to remove the family member from the family tree. Next, the option 5, show family members. This option shows all the family members. The get family member method of the family tree class is called to get a list of family members. The information name, gender, age, ID of each family member is then displayed to the user. Lastly, option 6 is exit, which exits the program, exits the loop, and terminates. Overall, the program allows the user to build a family tree by adding family members and relationship between them. It also provides options to edit or remove family members and displays the list of family members. The family tree is maintained using the family tree class, which internally utilizes the graph class to represent the family relationship as weighted graph. So lastly, I'll run my program to show you that it's running successfully. I'll run the CLI. So as you can see, we have the main menu. Next, we have we can see all the added family members by choosing option 5. So as you can see, we have all the family members. We have the name here, Patrick Earnshaw, which was the first family member in the doc group, the Word doc file. Gender, male, age 80 years old, ID 001, and the list goes on. Next, let's try to add a family member. So my next choice is 1, which adds the family member. I'm going to choose an ID that we haven't already inserted here. So I'm just going to put, let's say, 20. Then I'll enter the name Bob. Then I'll give the gender male. Then the age will be 50. I'll add a second person. So I can choose option 1. And the ID will be 21. The name will be Kim. The gender will be female. And the age is 51. Next, I want to show you that editing, adding a relationship works. So let's add the relationship between Bob and Kim. So I choose option 2. Then I enter the name of the first person, which is Bob. Then I enter the name of the second person, which is Kim. Then the relationship is married. Then it shows you added married relationship between Bob and Kim. So it has successfully added the relationship between Bob and Kim. Next functionality I'll show you is the edit member. So let's try to edit Patrick Earnshaw's age. So I'm gonna see the original age, so 5. So Patrick Earnshaw is supposed to be 80 years old. So I'm gonna change I'm actually going to change Bob's age. So Bob's age is 50 years old. So I will change edit Bob. So I chose 3 to edit family member. Then the name of the family member is Bob. Then I'm going to change the age. Then the new age will be 70. So as you can see, updated the age of Bob to 70. Next, since we have already edited a family member, let's try to remove a family member. So I'm going to remove Bob now. So I can choose 4. And then enter the name of the family member to remove, which is Bob. And we remove Bob from the family tree. And let's show family members. So as you can see, we don't see Bob anymore. And then since I have executed all the functionality and requirements here, I'm going to exit. Thanks for watching my video.